So we'll be looking at implementing security controls, detective controls, protective controls, and responsive controls across infrastructure security, data security, identity management. And we'll then be focusing on how we can automate compliance, on how we can automate our incident response. So those are the things that we want to focus in the discussion today, in this talk today, sorry. So starting with security design principles. Now, this by no means is an exhaustive list of design principles. They are very much driven by your internal requirements based on what kind of workloads you are running, but they have been more tailored to meet the content that I'm going to cover today. So starting with security at all layers of the design, so also known as what we call defense in depth. Now, defense in depth is not just about creating or duplicating technology, right, of what we commonly do, creating a WAF sandwich, having a web application firewall in the front end, having a load balancer, and then create another WAF at the back, right? So that's not really defense in depth. To have complementary technology which addresses your security concerns at each layer is what we are talking about. Visibility and trackability, absolutely important. If you can't see what's happening in your environment, if you can't see what's living, breathing, moving, you really don't have much control on your environment. You really cannot act when it comes to a security incident. So a really, really important design principle. Implementing the least privilege principle, right? Ensuring right resources have the right access in the right time, very, very important. Data-centric security design is a new one that's coming up, and we are seeing more and more customers now adopting a data-centric security architecture. Now, one of the key requirements with data security is that the security has to stay with the data. From the time you create the data, you store it, you share it, analyze it, archive it, and even when you delete it, right? You want to ensure that security stays with the data. So adopting a data security design architecture is really, really important. And finally, security by design. So if you look at how cloud has enabled us to do the security design, it has really changed. The focus is a lot more on security automation. There is a lot more focus on continuous compliance. So I'm going to take you through some of the examples on how we're going to implement this particular design principle towards the later of the session. So these are the set of AWS Security Services that I'm going to cover today. So I don't intend to walk through all of them, but just as a legend on what we are going to cover, what forms the part of our session. So starting with infrastructure protection. Now, so key requirements around infrastructure protection is we need to understand where we need to deploy or implement the security controls. What are those enforcement points? We need to identify the security boundaries. Now, by security boundaries, I don't mean that we need to look at what the perimeter is. I think we're beyond that conversation. We are not in an environment where there is a perimeter. But any of your AWS resource, whether it's your EC2 instances, whether it's your VPC, whether it's your RDS database, if there is an entry into your environment, you need to identify that and need to ensure that you're enforcing security controls on that. Implementing web application security and DDoS protection is an absolute must. So when you expose your environment to the internet, you are really exposing your environment to the web-based attacks, DDoS attacks. So we're going to walk through an example on how you can build a resilient architecture. Now, system security, I think patch, right? The security hygiene, it's really important. I've got a good example on how we can use the virtual patching technology using a WAF, and you can protect your environment from zero-day attacks. So I'll walk through that example as well. So building a resilient web-based application architecture. Now, there are two parts in this that I'm going to talk about. One is the DDoS part, which is a distributed denial of service, and the other is the web application security. Now, we earlier had a session which was a deep dive on DDoS, so I'm going to be pretty light at a high level covering the DDoS capability, but then we'll do a more deep dive into the web application firewall function. Now, talking about the design principles, right, we mentioned that we need to have security built into each layer. Now, if you look at this design, you have, at the starting, you have Route 53, a very scalable, redundant DNS service, which lets you manage how you want to distribute your traffic, whether you want to do it at a latency-based, whether you want to do it based on the weight, right? You can manage the weight. You can have 50% going to one availability zone, and you can have the remaining 50% to the other availability zone. Really important technique during a DDoS attack. The second layer is our CloudFront. So CloudFront lets you implement geolocation rules. So during a DDoS attack, if you are seeing traffic being originated from a certain country, you can block those countries. If you do only business in Australia and there is no need for you to operate outside or have users outside of the region, you can again implement controls to ensure that geolocation rules are applied. Now, the CDN integrates with the web application firewall. Now, the WAF can then provide you much more control on how you want to mitigate your DDoS attack. Now, once you are under attack, you can look at the pattern of the traffic that is originating. You can then apply custom rules in your WAF so that that particular pattern and that particular traffic can then be blocked. Now, if you subscribe to the DDoS service, which is the AWS Shield Advanced service, you have access to the DDoS response team, which can help you identify the traffic and also help you build the rules for you into the WAF. So moving on to the next layer behind your web application firewall and your CDN is where you have your elastic load balancer, your EC2 instances, and your databases, which are all part of your auto-scaling group. So typically during an attack, you would see that your environment will take a certain number of hits. And when it takes that hit, your auto-scaling policies would run, and then your environment is going to scale out. So again, that is very important from an availability perspective, so that the users who are genuinely trying to access your service have the service available to them, right? So again, auto-scaling really helps you in that way. And again, if you are subscribed to the AWS Shield Advanced, you get the cost protection, right? So you don't end up footing a bill just because during a DDoS attack, your environment ended up multiplying. This can also apply to your virtual firewall. So if you have virtual firewalls in your environment, they can auto-scale as well. You just need to be mindful of having the licensing arrangement, which basically lets you scale in, scale out. So that is from a DDoS perspective. So let's focus more on the web application side of things. Now, how can we ensure that your web applications are secure? Now, the AWS WAF is now available as a CloudFormation template. So essentially what that means, it's a push button install. So you can simply run the CloudFormation template, and it's going to activate your WAF. It is also going to implement the OWASP top 10 rules into it. So all those top 10 rules are built into the WAF, which you basically have no configuration to be done. So it's a zero-touch solution. But at the same time, you do get the flexibility where you can add your own custom rules, right? You will have some web applications where you have certain type of traffic coming in, and you want to identify what's malicious and what's not normal for that application. So you can set the criteria in as a custom rule as well. So coming back to the OWASP top 10 for 2017, so this year there have been a couple of new entries into it. And one of that is that I want to focus on is around the insufficient attack protection. Now, this particular attack vector is very important because it has multiple scenarios in it, right? And one of the scenarios that I want to focus on that you can implement into a WAF to provide yourself protection against this particular attack type is where you have a web application, right? So you have a web application, probably it's in-house developed, probably it is through a vendor, and there is a vulnerability that is identified in that. Now, the time that it takes for you to roll out a patch, which could be weeks, which could be days, so you have the in-house development team or a dependency on a third-party vendor to come up with a patch. Now, during that time, you want the protection for your web application, right? So that's what you call, the time the patch is available to the time the vulnerability is discovered, as what we call a zero-day attack. So you can implement a virtual patch at the WAF layer. So essentially what that means, if you understand the vulnerability, you know how the vulnerability is exploited, so you can create web ACLs and specify the match criteria on what is the HTTP request looking like, what is the URI size, what is the cookie size. Those parameters can then be defined so that you can create a virtual patch that can help you protect your web-based infrastructure. So we covered the shield. All right, coming to data protection. Now, key requirements around data protection. I talked about that, how you need to take a data-centric approach to your architecture. You need to ensure that the data is secure from throughout the life cycle. We want to ensure that the data is secure when it is in rest, when data is secure when it is in motion. And also, your data is then exposed to different compliance requirements. Based on whether it's PII, PHI, or it's cardholder data, you would have certain compliance requirements. So let's look at some of the security that you can use to build into your environment for data protection in particular. So we'll start with data classification. I think data classification is really important. It's really going to decide on how you're going to manage your data, how you're going to secure your data. Now, one of the key things, if you look into this architecture, is a very simplistic view, which talks about a government data center which has 5 different levels of classification. Now, you need to classify your data the moment the data is being created, right? You need to understand what the classification level of is, how you want to treat the data, what is going to be the impact if that data is lost or it's breached, and if there is a regulatory compliance requirements on that data. So essentially, data classification derives your overall requirements for how you're going to do your confidentiality, integrity, and your availability of your data. So in this particular scenario, you may decide that you want to keep your secret and your confidential data in-house in the government data center, and you want to move across the more publicly accessible data and your restricted data onto the AWS cloud. Now, what that does is that you can then apply security controls on top of it, right? So the data is classified, is sitting into the cloud, and you want to enforce the policies, right? So you can enforce the policies where you have, strict control on implementing server-side encryption. So you can say, okay, here is my S3 bucket, and I want to enforce server-side encryption. Nothing goes in. And I'm going to show you an example later on how we create a policy where you can enforce the server-side encryption. You can enforce multi-factor authentication. So if anyone is deleting any buckets, any objects, you can enforce that the users are coming through and authenticating using an MFA device. The other one is where you have versioning. Now, this is really important. And now, version control, yes, you can check the integrity, but version control also helps you when the classification of your data is being changed. Now, one of the challenges most of the news corporations these days is they will create the data. Now, before the data is created, before the article is published, the data is definitely classified at a different level. And the moment the data goes, or the article goes online, it is public data. And what these organizations are really, really concerned about is the data that gets manipulated by adversaries to modify the content of it, right? So it's really, really important when you're moving from a classification level, the integrity of data needs to be maintained. And the last one is addressing the availability. How do we address the availability of our data? So you can, again, enforce policies to ensure that your data storage classes cannot be changed. So if the availability of your data is highly available, you need to ensure that you are enforcing your users who are not allowed to change the storage class to a reduced redundancy storage. So how do we secure the data at rest, right? So we're just going to walk through some of the policies which will just show you how we can implement policies to secure our data at rest. So I talked about how you can secure by forcing the KMS. So in this example, we're going to deny every action to add objects into a bucket that you specify within the region that you specify, and it will use the key ID using the KMS. So this really enforces that anything that's going inside the bucket has to match. So we provide a condition in here that the string, if it is not equal to this, it is going to deny, right? Really enforcing the security on your S3 objects. Example of an IAM policy for your key management, right? We don't want our master key to be used. The reason we don't want the master key to be used is because the master key comes with some properties that cannot be modified. They're tied onto your account, they're tied onto your region, and it makes it really hard for you to move your data across if you have to. So we do not want that to happen. So in this case, we again create a deny where no encrypt, decrypt can be happened if for this particular resource in a particular region is using a KMS key, which is the customer master key. So master keys are identified with the alias of AWS with /. So this is how you identify it's a master key. So we create and build a policy which enforces that no one is breaking a rule where you have the KMS master key being used to encrypt data. Now, the KMS is very, very flexible. So we have KMS, our key management service, is integrated fully with the service offerings, right? We have for EBS. So all you need to do is simply check a box that you want to encrypt the volume, and you need to specify the key that you want to use it. Same is applied for S3, right? You simply specify that you want to encrypt it using KMS, and the same applies for Redshift, right? Very much built into it, right? So if you have security requirements where you need to encrypt your data, the heavy lifting of doing the entire key lifecycle management is taken care by AWS, and all you need to do is enable that service and check a box. Securing data in transit. So let's walk through some of the examples on that. Now, one of the key requirements when you're using HTTPS and you have TLS termination requirements to be done, one of the recommendations from AWS is always when you want to do TLS termination, do it on your load balancer, right? It's more scalable rather than terminating on your EC2 instance. But you may have conditions where you don't want to terminate on the load balancer, or you may want to do it onto the EC2 instance. Again, the flexibility is there. So you have the first option. You can simply terminate your encrypted traffic on the load balancer. So you load your certificate onto your load balancer. There is a policy attached to it, and the policy will then decrypt the traffic and will create an unencrypted session with your instances behind the load balancer. So that's an option. The second option is where you say, okay, I don't want to simply terminate it, and I want full secure end-to-end, and I want to renegotiate my TLS. So you can terminate your TLS in here at the load balancer, and then you can create another certificate using the policy that now the session that needs to be created at the back end needs to be done using a separate certificate, and you can then secure it. So that, again, is an option what you can do. And the third one is very much a compliance-driven. PCI is a good example. So PCI simply states that you cannot terminate SS or TLS sessions on anywhere. It has to terminate onto the instance that the application is running. So in that case, we can simply do a pass-through. Just pass through and let the instance do the termination of TLS. So you have the flexibility on how you want to secure your data and how you want to do the termination of this data as well. CloudFront. So CloudFront supports the TLS, and it has some very extensive capability, data security. So you can secure your data in transit. You can load your certificate onto your CloudFront. Now, CloudFront supports perfect forward secrecy. So for every session that you create, there is going to be a new private key that's generated. There is the OCSP stapling available, which is the online certificate status protocol stapling available. Essentially, what CloudFront is doing, it's going to check for the status of the certificate and going to return back whether it's valid or invalid and set up a session accordingly. You also have the option on how you want to distribute your traffic using TLS. So one option is where you can do a dedicated IP, right? So you create a globally unique IP. It is tied onto one domain. The downside is that you cannot do a scalability in real time. The other option is that you can use a SNI, which is a server name identifier extension, and this lets you, again, create a global IP. You can distribute the traffic to multiple domains, so there is no restriction, and you can do the scalability in real time, which again gives you the flexibility, and it is also a much cheaper option to do. The only downside of SNI extension is some older browsers really do not support that function, which something can be managed. So again, for securing your content in transit, a lot of flexibility available on how you want to do using CloudFront or how you want to do using the load balancers. Coming on to the CloudHSMs. Now, encryption, as much as it's about security, right, it's about control. Who has access to my keys? Now, CloudHSM comes in some really, really restricted, sensitive workloads where you need to ensure that the key belongs to you. AWS does not have access to the keys, and CloudHSM provides you that level, right? So the CloudHSM secures your master key. You are the only one who are in control of it. AWS has no access to that environment, and then you can run your restricted workloads integrating with your CloudHSM. So we launched a new CloudHSM service a couple of weeks back. So just referring to version 2, I'll just add some more clarity later on. So CloudHSM service that was launched, again, is the same type of service in terms of what a CloudHSM is supposed to do. It does the secure key storage. It provides a cryptographic function in a hardware which is tamper resistant. Essentially, any physical or virtual attack to the HSM leads into destroying of the keys. So that is the new service that is available. The older service, which was using the SafeNet appliance, is now referred to as CloudHSM Classic, right? So I'll just take you through the new offering and what are the differences between these two. So it's the first and the biggest differentiator that we've been asked by a lot of our customers that we want to have level 3. A CloudHSM, which is FIPS 140 level 3 compliant. So the new CloudHSM is now FIPS level 3 compliant. So we've got customers within the region, governments who are running restricted workloads, and one of the key requirement for them was to have the level 3, so which is now being met. So the older one still supports the level 2. There is no upfront payment that's required anymore. So in the CloudHSM Classic, we're using the SafeNet option. There is the $5,000 upfront fee, which is now removed. The high availability is ingrained into the setup, and I'm going to walk through the architecture in the next slide, and I'll tell you how the high availability is done. So, how you can add HSMs into a cluster, and auto recovery also happens. And in your old classic HSM scenario, you have the HA where you need to buy another box, configure it, and set it running, right? The console access is now available. So the HSM, as of now, is only available in 3 regions, in US East, West, and in Ireland. So if you want to try it out, you can look at the CloudHSM console that is available, making it much more easier to do the configuration. And the last one is the quorum-based authentication for M of N capability. So quorum-based authentication is where you want to have 4 or 5 or many people who need to agree in order to execute a function. So quorum essentially means that you will have 5 different people who have the security secret access of the HSM, which is split into different parts, and all of them then need to authenticate it in order for the workload to execute. So that is available now. And compared to the older classic HSM, where you need the PED, the physical PED log, which is the pin entry device, you don't need that. You can just do it using the 2FA secure keys. All right, so just looking at some of the features, fully managed clusters. So the way the new architecture works is within a region, you create your availability zones that are available to you. You create the clusters in each availability zones, and you can then add HSMs to it, right? You can add a maximum of 32 HSMs into it, right? And let's talk about some of the functions and the scalability that comes with those HSMs. Managed backups. So every time you create a HSM, there is a backup that is taken that's fully encrypted. So what that lets you do, it lets you recover point in time. Right? So you can do a point-in-time recovery of the HSM, and you can even scale up and scale down to 0 if you don't need it and stop your billing, and then recover and build a new HSM just from the backup. Automated replacement. So unhealthy HSMs are replaced automatically. Again, a good improvement to the classic HSM feature that we had. It's less expensive, so no upfront fee, as I mentioned, but there is also a 35% reduction in the ongoing fee. Large key storage, 3,500 keys that can be stored in a single HSM. More granular access control. You can create up to 1,024 unique users, and then they can manage their own keys themselves. So essentially, across 32, you have more than 112,000 keys and about 32,000 users that you can create. It's more secure. As I said, it's FIPS level 3 compliant, so it's definitely more secure. And it's standards compliant, so it supports PKCS 11, it supports JCE, so it makes it much easier for you to integrate your applications with the new HSM. Some of the use cases, so I'm not going to deep dive much on it, but what you can do with the new Cloud HSM, you can do your SSL offloading. You can use your HSM as a CA, so you can sign the certificates for your organization. And then you can also use Oracle-based transparent data encryption. So data encryption can be done using Oracle database, which is only supported for non-RDS, so it does not support RDS as of now. So in your classic HSMs, you could encrypt your EBS volumes. So one of the requirements comes that you want to encrypt your EBS volumes. You want to use your HSMs as the storage for your master keys. Now, again, this is done for restricted workloads, where the governments really want to ensure that, EBS volumes are secure, they are encrypted, and want to leverage the HSM. So this kind of architecture does require additional third-party software. So in this is only available for the classic setup as of now. So you will have the SafeNet HSMs running in here. So you need them to be integrated with the SafeNet Key Secure solution, which is essentially an equivalent of a KMS. The Key Secure then talks to a Protect vManager in between. So Protect vManager essentially controls the client that gets installed on your EC2 instances. So there's a fair amount of complexity involved into a setup like this. But again, this is something that's only possible using the HSM, classic HSM as of now. And then the encryption would happen where your EC2 instances communicate with the Key Secure, get the master key from the Cloud HSM, and perform the encryption function. TDE works the same way as it does in Cloud HSM as to the in the classic case as well. TDE, there is no additional software required. You essentially do an integration of the HSM with the database directly. It's just purely a software communication and configuration that's needed. All right, moving to identity and access management. So we're going to be looking at some of the advanced functions within the IAM side. So we all know that the IAM capability covers the role-based access control. So role-based access control is there. You have a role, you assign it to a user or a group, a user or a resource, and then you define policies, right? What you can also do is you can create attribute-based access control. So this is where you want to create specific conditions. You can specify the conditions. You can create if, else, then statements. And then you have more granular control on how you can do your IAM. So I'm just going to walk you through some of the examples. So in this one, the first case is where you want to enable a user to only terminate EC2 instance if there is an MFA device. So again, we're going to allow the EC2 terminating if there is a multi-factor authentication age set to false. In a second example, we set a condition where a user can only manage IAM users and the keys if they're coming over SSL. You can even tie it down to a source IP, so a user can only terminate an instance if they're coming from a particular IP address. So you specify the condition on what the source IP needs to be. And the final one where you can control your EC2 access and who can terminate it based on the tagging, right? So tagging is becoming more and more important. I've got another example of tagging to share with you. This is where you can force the tags, right, to a region. So here you are saying that I want to allow all the running EC2 instances and the volume attached to it and assign these tags to a particular region. So you're forcing these tags and you're assigning tags to it. And why it is important, in this case, we are showing how the classification of the data is being tagged to it. But the other example is that where you can control who has access to a particular EC2 instance just based on the tag that is assigned to it. For your security automation, you want to deny any security automation changes that you have done to your Lambda function, so you can create policies where no one can update, create, or delete any of the functions which have the security in it, right? So again, giving you more granular control on how you can manage the automation aspect as well. So coming to automating compliance, I think one of the design principles I talked earlier was visibility and tracking, right? How can I have the visibility and I can track my resources? So really important, why do we want to automate, right? It's very hard if you have a large environment, right? You have so many resources in it, you want to ensure that you can track them, you can ensure that the compliance of that can be tracked as well. So, this is the reason we want to ensure that we are enforcing the compliance requirements, we are having the visibility, and we can then take action. So AWS Config comes into view. So what does AWS Config does? So it takes a snapshot of all your AWS resources and puts them on a timeline for you. And it can track every change that is made to that resource. Now, this gives you not only the tracking capability, but it also shows you the relationship. So if you modify an EC2 group, which you may want to add or remove a port, it changes the state of your compliance state of your EC2 instance. So that is then shown as a relationship. You can then further extend the capability of AWS Config using config rules, where you are not only checking the status, whether it is compliant or non-compliant, you can generate a status. So you can send a simple notification service and send out an email saying, hey, there is a change to my environment, can you please look into it? Or you can use Lambda. So you can use Lambda, which can automatically fix the change that has been made. I'm just going to demonstrate that with the use case I have. So this is just a graphical view of how the config works. So config will record all the changes. It will normalize it. It will store a copy of the history of the snapshot in the bucket. It will have an API access where Lambda can access it, and it can also send notifications. I think an example will clarify this more. So just common use cases, why it is being used. Continuous monitoring, continuous assessment, audit and compliance, change management. So you can see some really, really good uses on how you can leverage AWS Config to achieve these goals. So here's an example where you will have a cloud security policy, and one of the policies states any web-based infrastructure or web server that is going online only needs to allow put ATN 443. So you create a config rule which is going to monitor that change. So if a user then goes and adds, say, SSH and opens it to the world, the config rule will trigger. The rule will trigger and it will send an alert. So you can send an alert using SNS. So SNS can send an email, say, hey, someone has gone ahead and made it and opened up SSH to the world. Or you can assign Lambda and give it the relevant permissions, and Lambda can go in and remove that port. So it gives you continuous compliance. It maintains your security posture. So we are joining security and compliance together, no longer compliance at the cost of security. So here's the example of the security group configuration. So this is available in GitHub, so just a quick snapshot of it. So we have two more security config rules that have been made available. This is very particular around the S3 access. So this rule can check if there is a global write and if there is a global read access. So these two config rules are available from the management console, and you can implement them and see, and they can run against your existing setup to show you whether you have the read or write access globally enabled for your S3 buckets. So this is the link to the config repository. So there is a lot of rules that are available that are ready to use for you. So moving on to responding to security incidents. So I think 4 key things which are really important when we talk about security incident, right? We want the right people to action the right thing in the right time and using the right process. Now, automation helps us to do that. So I'm going to walk you through an example on how you can automate your incident response. Some of the prerequisites, now in some cases, a lot of customers already have a forensic workstation built into their environment, but if you don't have one, you can simply create a base AMI, you can create the EC2 instance, you configure the instance, whether you're using Forensic Toolkit or you're using Access Data or any of those which run on the cloud, you can use that and you can configure the base. So it is just of the prerequisite that you have this forensic workstation ready. Now, again, a simplistic view of an architecture. So in this case, we have 3 web servers. So 3 web servers are part of an auto-scaling group. They're also attached to Elastic Load Balancer. So what we're going to see that one of these hosts get compromised. So when the compromise happens, a compromise could be as a result of a malware being detected. A compromise could be because you have seen outbound communication to a bad IP. So now once that happens, CloudWatch events get a trigger. Once they see the trigger, they execute the Lambda function. Now Lambda will then take or try to automate your entire incident response. And the first thing it will do is it will get all the information, right? So this is the command essentially which basically gives you which EC2 instance, what is the value. It will also insert some tags to it to say that I'm going to quarantine this instance. Then the second thing that the Lambda will do, they'll remove it from the auto-scaling group. It will also deregister it from the load balancer. Next, we want to contain this. We want to isolate this host. So we put it into a security group where no inbound, outbound communication is allowed. Right? So we essentially put it inside this security group. And the next important thing when we do that is that we want to take a snapshot of this one, right? It's very, very important that we take the snapshot in time because we know what happens during an incident response. There is a first responder who comes in, tries to run 10 different types of antiviruses, and you lose all the information that is sitting in the memory. So Lambda takes a snapshot, saves it onto S3, and the next, you can bring up your forensic workstation, right, to the base AMI that is created. So you launch the instance. And then that forensic workstation can do an offline analysis of the snapshot that has been created. Or you can also create a link to do online analysis. So it really automates your entire incident response. Now, if you look at this example, you can then start applying it to your incident response process within your organization and see how you can leverage Lambda to automate this function for you. There is also an open source tool, essentially does the very similar thing that Lambda was able to do. There is an open source tool which is more manual, so you can do similar level of commands to get the information that you need for an investigation purpose. Of course, you can probably script this as well, but yeah, as a second option, this is available too. All right, I think with this, we come to our end. So we've got some resources. The slides will be shared later on, so you can access these resources. But thank you very much.